Welcome everyone to the July 17th, 2017 Kubernetes SIG Apps. I'll start by sharing into the chat here the link to the meeting minutes for today. That'll have an overview of what we're going to be going over, and we've got quite a few things going on. Okay, so there's the link, and so I'm Matt Farina. I'll be walking us through this stuff today. The announcements, we could use note takers. If anybody wants to take notes, please jump in here. The more notes, the more details, the easier it is to find something when we go search for it in the past, and to share with others who might come across the videos or notes or be looking for something. Another announcement, it looks like Compose graduated through the incubator system. Congratulations. That's another one that's come out of SIG Apps that's graduated. The announcement email is linked here for anybody who wants to go read up on it and find out some details. And then the other announcement would be the 1.8 release schedule walkthrough. Dan, are you on to do that?
Yeah, I'm here. So can everyone hear me okay, I hope?
Sure can. Okay,
good. So yeah, there might be a little background noise because I'm at the airport, but just a quick overview on the 1.8 schedule is it's in GitHub, it's issue 305, and some of the key dates I just wanted to go over with everyone in the SIG is August 1st is the feature freeze, so make sure you mark that as August 1st, and then September 1st is code freeze, and then the actual release date is September 27th. So the final sort of code build is September 20th, and then the actual release is 27th. So that's really what we're working towards 1.8. So I just wanted to make that, communicate that out to everybody. Yeah, and again, if there are any questions, it's in GitHub. It's issue 305. There's a little bit of discussion there, but it's the dates I think are pretty much finalized at this point. And most of the dates I think are Wednesdays. They're not. Make sure that they're not Fridays. Okay.
All right, that's great. Thank you. And we'll move on here. We have one quick discussion topic that came up at the last minute for something called Operator Kitt. It's a proposal linked here. Is someone on to talk about it?
Yeah, sure. So hi everyone, this is my first SIG Apps meeting, so it's great to meet everyone. The second thing I wanted to just very briefly introduce is a project that I've been working on with a few other people in terms of operators. So if you're not aware of what an operator is, it's essentially a code base which automates some kind of manual process that a user traditionally does. So one example is the etcd operator by CoreOS, which sets up a cluster. It manages like all the reconciliation state, it provides upgrades, backups and stuff like that. And usually a user would have to do all this themselves, whereas with an operator you sort of declaratively program how you want that sort of the life cycle of that app to operate. So yeah, so an operator is pretty cool. So a lot of feedback. Is everyone muted? Okay, cool. Yeah, so we have a bunch of operators in existence right now. CoreOS have a few. We also have Rook, which is a similar kind of thing to the etcd operator, but it manages the life cycle of Ceph. And we have a few by Giant Swarm too. And although like all of these projects are super awesome, one problem which we've run into initially is that we see a lot of duplication across code bases. People are solving the same kind of problems in, you know, at the best of case, the same way, in the worst of cases, divergent implementations. So we came up with the idea of having a shared code base, an operator kit, where people have a common library or an SDK to write their own operators, and it sort of establishes best practices and, you know, hosts all this common code. And one of the aims is to sort of really promote people writing their own operators over time and sort of encouraging them to get involved, basically. So the current state of things is that we have a proposal. One of the things that would be great is to have more feedback on that. So if you're interested in reviewing that document, I can post it in the Slack. It's also in the meeting notes. So I'd like to solicit any feedback, whether you think it's a good idea, whether you think we're missing any potential features there. And then the second thing which I'd like to do is, if it all looks good to people, is to propose it for incubation. We already have a bunch of interested people willing to help out with it. So CoreOS, Giant Swarm, Rook, and myself are interested in creating this code base. So, I was speaking to some folks from CoreOS, and they suggested that SIG Apps might be a good fit. So, if I just want to hear people's feedback on that, whether they think that SIG Apps could be a good sponsor. If not, what would be a better fit? So, in a nutshell, that's about it. If there are any questions, feel free to ask them now or ping me on Slack. Yeah.
So I'll jump in real quick here. I think SIG Apps is focused on the development and operation of applications inside of Kubernetes. And so I think this is probably the good fit place to see how this ends up going. Are you familiar with the process to go through incubation to come out?
Yeah, so I read the documentation on it, and the two things that we need right now is a champion and a SIG to sponsor. So Antoine from CoreOS has volunteered to be the champion, and he suggested that SIG Apps might be a good sponsor. So once we have a SIG as a sponsor, the next step would be submitting the proposal to Kubernetes Dev. So we need that SIG as a next step, basically.
Okay. Since all the SIG leads are none, let me, we'll take this to the mailing list, and I'm going to run it by Adnan and Michelle offline, and we'll get back to you. I think this is probably the best place for it, and let's see where it goes. I'm just not going to speak for lots of folks who aren't here and in the PMs and all of that stuff ahead of time, because we've got to move on. So is there any other last minute feedback to this? Any questions?
Can I just ask a quick question?
Of course.
Yeah, thanks. My name is Mike. So I'm looking through the proposal here, and I'm just kind of trying to understand this. This is the operator kit would be something to kind of help you automate deploying things into a running Kubernetes or configuring it. Is that?
So the operator kit is essentially like a common library that other operators would use. So you wouldn't directly, so if you just want to deploy an app to Kubernetes or you want to deploy the control plane, you wouldn't directly use this. It's not something that I envisage sort of most end users to be using. It's more sort of people or companies who want to write their own operators. So if for example, if you want to make MySQL deployments easier to manage and you want to take on the work of writing an operator for that, then you would use this operator kit to do a lot of the common functionality that you would use in order to do that.
Okay, great. Thanks a lot.
All right, if there's any other feedback, please head over to the proposal or follow up in Slack afterwards, or hit up on the mailing list. Thank you. I expect we'll be talking about this in the future. And so the next thing we have is a couple of demos. And so the first one is a Forge demo. Do we have somebody on? Raphael, are you on to do the demo, or somebody else?
Yes, I'm on. Can you hear me?
I sure can. The floor is yours.
All right, thank you. Let me see if I can get my screen share to work. Let's see. Can everyone see my browser? Or can anyone see it?
I can see it.
All right, awesome. So I've got a couple slides here, and I just wanted to sort of give a little bit of background, just sort of context, so you guys can understand sort of where Forge came from. So first of all, myself, my name is Rafi Schloming. I work at a company called DataWire, and we've been helping people with microservices since about 2014, and we've really focused on what developers need to build these sorts of cloud applications, everything from the enabling technology to stuff like Kubernetes, to the organizational changes and the dev tooling that kind of goes along with all of that. And since about 2014, we've worked with a whole bunch of different organizations at different stages of adopting microservices. And we really kind of discovered that from a certain perspective or at a certain level, the dev and deploy cycle remains pretty constant throughout this journey. You're always doing this sort of same, change, make a change, measure the impact of that change, and diagnose any potential problems. So at that level, it stays the same, but what you actually need to optimize that cycle really changes as you go through the journey. And we found it sort of helpful to think of that in 3 different stages that are defined by sort of how the definition of what a successful deploy means changes as a project goes through these different stages. So we think of stage 1 as sort of rapid development. You might have a few early users, but really a deployment is successful pretty much if it doesn't crash. Stage 2, you start to have a little more users. You start caring more about disrupting those users. And at this stage, you need to take steps to ensure that your changes minimize any potential disruption to those users. This is when you start seeing sort of canary workflows being introduced and things like that. And then stage 3, and not necessarily every service gets to this stage, but stage 3 is you start having internal users, right? This means that the overall organization is going to have more potential coupling, and you have to start worrying about things like cascade failures. And again, you see more tools being introduced at this stage to deal with minimizing cascade failures, minimizing the impact of those kind of things. This is all sort of told from the perspective of a single service, but one of the things that's sort of challenging for organizations as they go through this journey is that they actually need to build a platform that supports many different services at different stages, all sort of interoperating at the same time. This is key to one of the benefits of microservices, because you can develop new functionality as a separate service. You can stay in that sort of rapid dev prototyping mode without having the impact if you're adding functionality to an existing stable service with lots of users. And so this is really the context for Forge, and this is one of the reasons we built it on top of Kubernetes. Kubernetes is great for running applications that are composed of many, many, many services, and Forge really just fills in some of the gaps when it comes to the dev workflow around this, right? It's not so great at running source code. I'm sure you guys all know the sort of the mechanics of making a source change. You need to track down the source code, do a Docker build, compute potential image names, tag, push, munge your manifest, and do a kubectl apply. And when that gets in the middle, right, plus on top of that, you have potential dependencies for other services to worry about. And that really starts to get in the way of a productive dev workflow pretty quickly. So Forge really just tries to sort of fill in the gaps necessary to use Kubernetes in a very sort of natural way. And we don't try to sort of hide Kubernetes. We expect you to know and understand Kubernetes and the basic concepts, but we sort of streamline the workflow. The workflow around developing an application that's composed of many services. So how does it work? It's pretty straightforward. Every service, you can have one or more services in a Git repo, actually, so you can use monorepo style or separate service or per repo if you want. Forge just searches for Docker files. It will build anything via those Docker files. It searches, or you define how those Docker files are deployed via templated Kubernetes manifests, and it looks for a service.yaml to understand dependencies and metadata about the services. Then when you run Forge deploy, it gets those dependencies and metadata from the service YAML. It builds all the services and dependencies based on those Docker files. It pushes the updated Docker files into the Docker registry for you. And it instantiates the Kubernetes manifest with the metadata from service.yaml and from the actual build. And it will run kubectl apply to deploy all your services. And so it will do that intelligently, incrementally, and it will do that in parallel. So you can use it on many, many services, and it will be pretty efficient. So to illustrate this, I'm going to show you, this is actually, well, I'm going to show you a demo of what Forge does. The application I'm showing you is actually a real, it is a real sort of proof of concept I'm working on. And it consists of 4 services. I have an API gateway deployed. That's actually Envoy plus a little extra plugin that we have that delegates authentication to an external service. I've got an external service that's responsible for doing authentication. It happens to integrate with Auth0. And then I've got, right now they're just stubs, but I've got a tasks service and a search service. So, this is going to be a to-do application that's a proof of concept of sort of this authentication, this authentication architecture. So let's, oops, no, wrong. So, can you guys see my screen here?
Yep, yeah. I can see it.
Sorry, you can, here, let me, so this is my to-do service, or this is, I've chosen to use the monorepo style here because I'm working on sort of a single integrated example. And so I've got, at the top level, I've got my API gateway, I've got my auth, let me know if the fonts are big enough. My auth service, and then tasks, and search. And so that's my 4 service.yamls. And just to see what service, these are the contents of service.yaml. All that's really defined for the API gateway is just the name API and the fact that it requires the authentication service to function, and then some additional metadata that gets plugged into the templates. So this is, in this case, this is the target port of the service, the memory limits, and the CPU, or the memory and CPU resource limits. And most of the other service.yamls look pretty much the same. You can see I don't have any deployments right now, and that I can, I'm just at the root directory here, I can do a forge deploy, and it will, in parallel, do Docker builds and build, bake, or build, push, and apply the manifest. Actually, the reason this is, that's pretty much done at this point. This is actually pretty fast because one of the things it does is it detects, based on a hash of the input source, that Docker images have already been built for this, and so it just uses the existing Docker images. But my deployments should be there. I can, well, okay. I can go for and look at my tasks stub, but without my authentication header, I don't get anything. With my authentication header, I do. If I want to make changes to my source, I can pretty easily go here, and this is my app service here. Sorry, this is my authentication service, so I can add some stuff here around requiring scope. I can add additional logic to my authentication service. Do another deploy. It detects what needs to be rebuilt for that. Does that, and tells me, okay, I don't have appropriate privileges for accessing that particular service. So that's pretty much it. This is designed to work nicely with sort of some of the other tools we have, like telepresence. So this lets me spin up my service network. If I wanted to do a more rapid thing, this is something I actually did yesterday as I was debugging this. I can also do something like, because I have the whole network running in my own cluster, I can run telepresence and intercept the authentication service. And this is something I would not want to do in a shared cluster, because anything I do locally is going to impact everyone else's productivity if I have broken code. But I can here. I can see. As you can see, I'm now running the auth service locally on my box, which means whenever I change things like this, right, it's going to live reload, and I can get right back to the tasks service. So that's kind of. Let me go back to my slides here. That's kind of the story for what it does. Sort of the main use cases that we've developed this for. There's actually a couple different things. So if you think about the main use cases are things like local development. So you can spin up your own, if you're like a small team, if you're one team working on a multi-service app, you can use this to create a really nice local dev experience just by running everything in Minikube, have your own isolated dev environment. If you're sort of an organization where you have many teams working on many services, you can use it to set up shared isolated dev environments. It's useful in testing, so you can use it as in the basic or in your CI system to install your app from source and run tests on it. And it's actually useful because it's available as a dev tool as well, so you can run just one test in exactly the same way your CI system does. And then another thing that we use this for is knowledge sharing. So you can and one of the great things about Kubernetes is you can sort of distribute and package up all the operational stuff necessary to run a whole network of services. But when you share it that way, if all the YAML you pass around just points directly to Docker images, it's not very modifiable. So we use this for knowledge sharing. You can share share something in a way that's really, really easy to modify the source code and sort of adapt it to your own needs. And let's see, I think I covered features. Oh yeah, there's a plugin system. So we can automatically apply certain transformations like Istio, like the kube inject stuff. We can apply that automatically if you're using if your deployment templates need to be modified in order to integrate with Istio. Let's see what else. Like I said, it's designed to be really, really fast, so it takes advantage of all of the existing Docker images in your repo. It does dependency managing. So if you're sort of on a larger, if you're a larger scale application, it knows how to just pull down based on the service metadata, the subset of services necessary to stand up whatever it is you're trying to deploy. And then we use the templates we use. So let's see, I think I didn't actually show you the templates, but so this is the manifest template, and it's just using sort of standard Ginger 2 templating, which we kind of picked because that was already in use at sort of the first organization that we built this for. But it's proven pretty useful in that you can actually eliminate a lot of boilerplate with sort of the Ginger 2 templates, and you can enable another kind of knowledge sharing. The people that sort of write the templates and sort of can define best practice deployment templates, aren't necessarily the people writing the source code, and so you can have the sort of division where you can plug in sort of key things from your service.yaml, like the resource limits, and have those plug into best practice deployment templates. So there's there's a couple other tools that are kind of similar, related, possibly in some ways, or overlapping. We've seen, you know, a lot of the people we've worked with use Docker Compose for similar workflows. You know, basic difference there, Forge is obviously designed to work directly with Kubernetes, and there aren't really the same operational features that Docker Compose has. And there, you know, Forge doesn't have that sort of single monolithic YAML type view that Docker Compose has. It views sort of your network of services as a network, and tries to enable you to stand up whatever subset of that you want to. There's Netflix Newt, which is well, it's not super. There's been a couple talks about it. It's not open yet, although I think they're talking about open sourcing it. It's a very, very similar idea in a lot of ways, but built inside Netflix, and because they're not, you know, because they work with EC2 and sort of their own container platform, they're less container centric, but very, very, very similar in a lot of ways. Newt also, just because of where it started, focuses a little bit more on project bootstrapping, that aspect of the workflow. Draft, some of the differences there. Forge is an entirely client-side tool. You don't need anything. You don't need anything on the cluster or running in the cloud. There's no like central server for it. It just uses, you know, whatever Docker registry you point it at and whatever Kubernetes cluster you point it at. Another difference between Forge and Draft there is Draft produces Helm charts, and Forge just uses the Docker images and Kubernetes manifests directly based on the Ginger templating. And I don't know if Draft does anything with dependency management currently. So that's pretty much the story. Happy to answer any questions. Hope I didn't take too long there.
Can you put a link to the presentation in chat?
Oh, absolutely. Let me make sure it's public.
Yeah, you can do it afterwards. We can have maybe 1 or 2 questions. Did anybody have any questions? All right, I'm going to take silence as we don't have any. If you have any other questions, feel free to put them in the chat and they can be answered in the sidebar or take it to the mailing list or Slack. Thank you for the presentation. This was great. There's a real problem space that is being kind of attacked from multiple different points of view of how do we go about operating this, and especially how do we also develop along that type of stuff. And then the separation of concerns between development and operating at scale and all those things. So thank you. This is useful, and I hope it was useful for somebody. And we have another demo today, which is CubeDB. Is anybody on to talk about that?
Yeah, hi, this is Kamal.
All right, the floor is yours.
Okay, let me share my screen.
I can see your screen.
Okay, great. Yeah, so I'm Kamal. I'm from AppsCode. So CubeDB is a project for running database systems on Kubernetes. So this is actually based on, this is actually a collection of operators for various databases. Currently, we have implemented this for Postgres and Elasticsearch. So to give you the background, basically, we started running our own SaaS platform on Kubernetes, and we needed, you know, a way to run our databases. In the beginning, we were using like replication controllers and all those kind of things. And once the stateful set became, you know, a thing, we started migrating to do that. But there are always issues. How do you like take, you know, your database snapshots? How do you sort of recover from those snapshots? And sort of the whole lifecycle management wasn't really easy. So we developed this operator-based system. We are calling this CubeDB. So to deploy the system, basically you can go to the CLI project. So it is open source on GitHub. It is actually under the Kitt DB GitHub organization. because CubeDB wasn't available, but we call it CubeDB. So to use this system, you can go to the release GitHub releases page and actually download pre-built CLIs. So we have like say pre-built CLIs for a bunch of different operating systems. So today I'm going to demo this system using a Kubernetes 1.5 cluster running on AWS. So, so this is my terminal. To demo this cluster, so I have basically pre-deployed a few things. Basically, I have a Prometheus running on this cluster, and I also have a PG myadmin running, so that I will use to show that once the database is actually running, you can connect to it and actually run queries and things like that. So now first you can deploy so I have already the CLI installed. Basically you download the CLI and copy it to basically your path folder, like user local bean folder, and that's all you need to do. So here, once I run CubeDB init, so in this particular cluster, I already have it deployed. So once it is actually deployed, this runs a CubeDB get pods. It runs a operator pod, CubeDB operator pod in the kube system namespace, and it also runs a service with the same name. Okay. Now, I'm going to use a demo namespace for all these demo operations. So this is the TPR that will create a Postgres database. So there are like a bunch of features that's present here. So first it says that this is the version 9.5. So we are actually using Kubernetes, Postgres 9.5 database, because that's what just we are using in our production system. So this will actually dynamically create a stateful set, and it will use a deploy PVCs using the dynamic provisioning, storage provisioning. So we have a storage class in this cluster, which we call GP2, which is the GP2 storage class for AWS. And then I'm also come back to these sections later. So let me first create this database. So CubeDB create -f docs. So it will do some validation, and then if I do CubeDB create PG, and here's all namespaces. So you'll see that it has actually created this P1 database in the demo namespace. So it is actually still in the creating process. So as you can see, so it is now actually in the status running. It has created a storage class. It is using a storage class with 10 GB disk. It has created a service called P1. It has automatically created a database secret for the Postgres root super user. And then it is also actually configured a monitoring system using the CoreOS Prometheus operator. And then you can also see the various events that was created. So if I actually go like cube serial get stateful set, you can see this is running. It also created a new storage volume. Now, as you can see, this created a secret for the database system. So if I get the secrets, so it's called P1 admin auth. So if I take this secret and decode this, So this is actually a ini formatted file, and inside it only has like one key value pair, which is the Postgres password and the actual password. So if I take the kubectl get pods and demo, yes, I need the pod IP. Yeah, so this is the pod IP. So if I take this pod IP and go to the PG admin that's running in this cluster and sort of connect to this database, so say new server. Give it the name P1. The root user Postgres, and the Postgres user has the password, as you can see here. Save. And if I connect to this, you'll see that this database is now running. And now you can, it has like a, it has, so it has the public schema, if you're familiar with Postgres, and then we also created a data schema when this was created. I'm coming back to that. So this database is now running. Now, if you go back to the two other sections that was in the spec, we had a monitor section which said that I want to create a service monitor which will be created in the namespace default, because my Prometheus is running in the namespace default, and then it will have the service monitor will have the labels app:/CubeDB, because that is the service monitor selector this particular Kubernetes, the Prometheus is using, as you can see here, this part. So now, if I go to the Prometheus that is running here, if I refresh, you'll see that it has basically automatically ejected this P1, the database, the database pod that is running. So it is basically running a sidecar Postgres exporter, and it is coming from the demo namespace, and there's the pod P10, the service P1. And if I actually go here, kubectl get service monitor, I'm not sure why this is not showing here, but it is actually created a service monitor. If you go to the configuration, you'll see that it has this is the job that has been created based on the service monitor. Okay, and then in the database, we used one of the thing, which was I mentioned that it will going to use a init script. So basically, I wanted to initialize the database with some additional schema that is not present in the standard Postgres, just to show that we can actually use a init script if you want to initialize your database with some SQL databases and things like that you want to. So for this example, I'm basically using so you have to specify a volume which will be used, and then you specify a file in that volume that will be used to initialize the database after the database stateful set is created. So here I'm using a Git repo that I have created ahead of time. So in this Git repo, there is this run.sh file, and this sh file basically runs the psql command using the Postgres user. So this is running as the local host, so you don't really need any password. Is a super user mode, and then that actually creates this, runs this. This is just a demo SQL file, a SQL file, so you can use anything you need for your project. So this creates a schema. There's a data schema that was there, and then it also creates a dashboard table in that schema. So so that is this data schema that was created, and then in the table section, table is actually under the let me refresh. Yeah, so the tables is under the data schema. So this is the dashboard table that was created using that in each script. So now if you want to take a backup for this database, what we can do is basically we have another TPR object. We call it Snapshot. So you create this Snapshot TPR object. In the object, you specify which database you want to take a snapshot of, and then you also have to specify the type of the database. And then you have to specify two more things, which is so we can take backup into any kind of cloud, any of the major cloud providers, which is like Azure, Google Cloud Storage, S3, Swift, or even it can take backup in a local file system. So if you are like running a bare metal cluster, and if you have a mounted like a safe, mount or cluster FS volume, you can actually take backup into those kind of things, or any kind of NFS volume. It's up to you. So for this demo, I'll show that the cluster is running in S3, but I can actually take a backup in like a Google Cloud Storage. So to use Google Cloud Storage, you have to create a secret, which is the credential for the Google Cloud Storage. So that secret has basically two fields, which is the Google Cloud project ID, and then you have the service account JSON key. So it's actually the JSON file that you can download from the Google Cloud Console. That's essentially JSON encoded into this. I can actually show you so this was the JSON file that was used. This is already not valid anymore, but you can see the demo. So now, if I go and create this snapshot object, so this is from PG3 YAML. So once this job is actually, this snapshot object is created, the operator nourishes this, and then it creates a Kubernetes job. So it is running this job 9 seconds ago, and our database is empty right now, so it will be pretty quick. But so if I run CubeDB get snap, refresh all namespace, I can also see the snapshot that has been created, and it's now running in the state. So if I do CubeDB get PG whole namespace and describe the P1 database. So I'll say that the snapshot process is running currently, and once the process is complete, if I go to this is the project where this should show up. So it will have this CubeDB. It will have, so this is so CubeDB is like a prefix that we add, and then the demo is the namespace name. P1 is the database name, and this is the snapshot name that I gave here. So snapshot XYZ, and then inside that it has the dump file .sql. So this is the PG dump command that we ran. I mean, the job ran automatically, and then that's the output of that process. So
All right.
yeah. And then a few more things you can do is basically.
I hate to cut it off, but we do have other things, and we're starting to run short on time. This was a great demo, and if there's more stuff, we can probably bring you back to do some more demos. But we've got a couple other things we need to get onto.
Yeah, thank you. So if you're interested, you can connect to us on our GitHub project, and yeah, we're happy.
Yeah, this is really cool, and maybe we can do some more bite-sized demos in the future of some of the different parts of this. Thank you very much. No, this looks fantastic. And if folks have questions, please put them in the chat, and we can try and get them answered over there or carry them over to Slack or the mailing list. I'd love to see more of this in the future. Thank you.
Thank you.
All right, the next thing we have up is actually to do some planning for what we're going to continue to work on next. And this is a follow-up from last week with the Kubernetes core and Kubernetes tooling functionality. There's another document for this planning, and we've only got a little bit of time left. I just dropped in a link to the planning. And so some of this is filled in, and this is kind of what we're planning for, not necessarily what we're going to do. And unfortunately, I wasn't here last week at least I don't think I was here to be part of the planning for this. So we have the Kubernetes core, and we have stateful sets, daemon sets, deployments, and replica sets, cron jobs and jobs, improving TPR support, and then I see defer containers. Is there anybody to lead us through this, or I can?
I mean, Ken or Eric, if you're on, you can also help as well.
Yeah.
Just to clarify, this doesn't list everything we're planning to do. This is list everything that anyone who wanted to type in this doc wanted to do.
Okay.
We may have to go through a process of focusing our efforts to make sure we get our priorities done.
Okay. Thank you for that clarification. I was not aware of that. All right. So let's start with it. This is what everybody wanted to do. And at the moment, you're going to notice that we don't have names next to any of these. And so I think the next steps are to fill out what folks want to do, and then prioritize and get organizational names next to these as to who's going to work on it.
You want to suggest a process for prioritization, Matt?
I was actually going to ask you the same thing.
Okay, so my suggestion is that a lot of these controllers have been hanging around in beta for a long time. At least people we talk to would like to know when we're going to get to GA. They'd like to know that Kubernetes is going to get finished. That's what I hear. From my standpoint, I think it'd be a cool goal for us to be done at the end of the year with these controllers moving to V1. Doesn't mean we can't have a V2, beta 1, or alpha right after that, but like get to a stopping point where we can stabilize the docs and people can count on that for a long, long time, support of that V1 version. So then if we want to do that, if we agree as a SIG we want to do that, then I think that kind of informs how we have to prioritize the amount of time we have. Any thoughts on that?
That sounds like a great idea. Getting to stability will influence the use of it, and then we can actually start to learn a whole bunch from it being used, and then we can continue to improve on it and discover where breaking changes really need to come in. But as long as we're breaking things all the time, or there's potential for that, that's gonna, cause people to not use it or treat it the same, and so we can't learn as much. So I like the idea of getting to stability, and by the end of the year sounds like a great time frame.
So I'll go a little further and say that if we want to get to stability in 1.9 GA, then we really need to do most of the work in 1.8 and just have 1.9 kind of as like a soak period, I claim, just so that if there's any last minute things, we fix that. So I would think that we really need to look at this list and say, what can we do in 1 quarter to bring this to GA? Let's keep 1.9 clear. That's my take.
I like it.
Any other thoughts on that?
I like it.
The only other thing I would say, The other thing I would say is like there are a few things that we know we're fairly confident that we want to do going forward. So as we take this API surface and try to move it toward V1, we have to make sure that we do it in such a way that we don't pigeonhole ourselves from implementing things going forward. I think most of the core things that we want to do, we are aware of, and we kind of look at the API and we have confidence that like we can implement this later if we choose to do so. We just want to make sure that we're at a place where, you know, we stay confident that with that as we go to V1.
That makes sense as well. It gives us the ability to later go back and add features, but do it in a way that doesn't break backwards compatibility.
Yeah. So I think that most of the things that we should do should be things where it's a continuation of something that started and we have feedback on it, not a really brand new feature. Not to say that there won't be any of those, but mostly it should not be brand new features.
Or it could it be new features that make changes, but do it in backwards compatible ways?
Someone in a car should mute.
So what do you mean by make changes but do it in a back? Like if we're stabilizing the API service, like there's nothing to say you can't add things to it that won't, you know, that we're not going to choose to try to deprecate later, basically. Like we should be confident that whatever we're going to try to advance forward is something that we want to stick with. And then, you know, there's nothing to say that we can't also have a GA, beta, alpha API. You can add new features to 1 and 1.9, but not to the GA API.
I don't know. I would want us to politely say no to anything that adds risk without driving us towards that GA goal. And then we can just take all that risk after, you know, after 1.9. Yeah.
Which makes sense. I mean, like modifying the core controller logic to add a new alpha feature that's not super critical is probably just going to increase the risk of advancing it.
Even if it's like in its own code area, it's still like causing E2E test churn review load. It's just slowing us down for we have a fairly tight time schedule. Sorry, I feel bad that Ken and I are dominating the conversation. I want to stop and make sure we get feedback from others.
Good question. This is Deepak Krish from Huawei. So how about the design review? So I know, so code merges, obviously we don't want to do that, you know, as part of the stabilization effort. Is there an opportunity to kind of do the design reviews though, so that if somebody wants to kind of develop it internally and we can go ahead and do that as long as we have some kind of a consensus from the community as far as the design is concerned? Is that possibility though, or is that not a possibility as well?
I mean, I think it can't be a guaranteed time slice. Like I think hopefully everyone who knows the code best to review it is going to be working on bringing all 4 controllers to GA. If they have spare time, that's nice to do design reviews, but it can't be a budgeted thing, I don't think.
Are you thinking of deferred containers in specific?
No, so there are 3 things we proposed. I think Dilip is there on the call as well. The default container and the 2 other things, the update, the rollback, you know, the automatic rollback, and there was another one. So what we were thinking was if we can get some kind of a LGTM on the design review, then we can go ahead and start doing that internally, the code development. That will kind of help us.
So deferred containers is one thing. Autopause was the other one, or was it automatic rollback along with something else?
So there are 3 of them. It's an automatic in-place update and the automatic rollback and the deferred container. These are the 3 ones we were.
So in-place updates, we don't do container resizing right now.
Okay. So rather than litigating a specific issue in the SIG Apps meeting, maybe we can define a process that we need to do for contentious stuff.
Yeah.
So maybe we can identify stuff that everyone agrees needs to go in soon, and then stuff that's contentious, maybe we can have time slots in the next couple of SIG App meetings to have, that will be basically an in-person design review conversation.
Yeah.
Does that sound good, Matt?
That would be perfect. I mean, if we can get some kind of a design review, yeah, I think that's exactly what we are looking for, yes.
Okay, so how about this? One of the things that we did in the past was we took these and we put them, I think it was into a spreadsheet. And then at the top, you'll notice we've got the group codes for what organizations are interested. We can put those across the top, the features along the left side, and then we'll have a space for other for those of you who are not part of one of these organizations. And then we can tally up which organizations are interested in which features to try to figure out which ones we want to get in the 1.8 time period. And then we can also talk about 1.9 will be focused on stability of what we have. And we'll run that by to see if we're still going to do that. So by the end of the year, we can release V1s of these controllers.
Well, yeah, I think so. We're not really pushing for these features to be included in 1.8. What we're saying is we definitely agree with the stabilization idea, the GA release. We agree with that. But as long as we can get some kind of approval for the design, then we can keep developing it internally. So that way it doesn't really conflict with the stabilization effort.
Yeah, but we can still add more features into 1.8, and what we want to do here is try and prioritize which ones we find to be interesting and find out where there's overlap between the different organizations and developers who are interested to see which features they want to get in. And a spreadsheet may help us do that.
Okay, so I think that's fine. So we'll go ahead and do that then, yeah.
Okay, and I'll take the action to start that spreadsheet and carry that detail over, and then I'll put it out onto the list.
Is that done? Is that done?
It's not done. I said I'll take the action to create it.
No, are you done?
No, this is Matt. This is Matt.
Matt
okay.
Farina.
Yeah.
Okay.
Sorry, Matt Farina. Yeah, I'll take the action to start that list. I'll get a chance to do it either this afternoon or tomorrow sometime.
Great. That'll be great. Thanks.
And then I'll send it out on the list, and we can start to fill in the details.
Thank you.
All right. So we've run out of time to dig into all the Kubernetes tooling. I will say that Helm has some details here, and they do have a roadmap in the form of a roadmap and a release cycle. And I see some details in here about Monocular and the app registry. There are a number of others here, such as, and Draft has some in, but OpenCompose, Compose, which just graduated, it should have a roadmap we can link to in here. Charts and App Controller. It would be great to have some details put in here to figure out where we're going to go in the 1.8 timeframe. So if somebody's on for one of those projects, if offline you can fill in some of those details, it would be great. Matt says the draft and Helm items in here are accurate. Thank you. And so with that, are there any final comments before we end for the day? Thank you, everyone, and we will continue planning next week. Have a wonderful week.